When night settles in and the outside world gradually grows quiet, perhaps the deepest fatigue is not in the body but in a mind still crowded with noise. Thoughts left unfinished, questions without answers, invisible pressures that daylight teaches us to call normal. In this quiet space, this video does not invite you to understand something new, but gently invites you to release very softly what is no longer necessary. The universe may be hiding forces we've never seen is not only a story about the cosmos or about physics. It is a slow inward journey where unseen forces do not merely shape the stars, but quietly influence our emotions, our memories, and the way we exist in this life. Here, there is no right or wrong, no conclusion you must remember, only questions whispered aloud told in a rhythm slow enough that you are not required to answer. As Carl Jung once wrote, the least of things with a meaning is worth more in life than the greatest of things without it. So if you are tired, let your mind drift gently. Allow this story to guide you into a space of stillness where you do not need to try, only to listen, and little by little give yourself permission to rest. For centuries, humanity has lived with the sense that this world, no matter how vast, could ultimately be explained by a finite set of rules. We gave them names and called them the fundamental forces: gravity, electromagnetism, the strong force, and the weak force. These four forces are like the universe's quiet heartbeats, enough to keep galaxies from flying apart, enough to bind atoms into matter, enough for the sun to keep burning, and for life to continue unfolding. But as we listen more carefully to the universe, those familiar heartbeats no longer seem sufficient. There are motions that do not fully follow prediction, gaps in understanding, phenomena that feel like the faintest whispers suggesting that something may still be present, though not yet named. Today, scientists no longer ask questions out of simple curiosity. They ask because the data itself has begun to feel strange. Galaxies rotate faster than familiar gravity allows. Space appears to be expanding at an accelerating pace, as if an invisible force were gently pulling everything apart. Inside particle accelerators, where fragments of matter collide at unimaginable energies, there are subtle results that resist explanation, tiny cracks in what once seemed a complete picture. And from this, a very human thought emerges. If what we know is not enough, might there be hidden forces quietly at work? What is striking is that this question does not belong to physics alone. It touches something deeper in the way we face the world. For in our inner lives, we also live alongside such invisible forces. Memories that have never been named. Emotions without a clear origin. Sadness that arrives and leaves without explanation. They do not present themselves clearly, yet their influence is real, like dark matter of the soul. When scientists speak of dark matter or dark energy, they are not speaking of darkness as something frightening. They are speaking of things unseen that leave traces behind. We do not see dark matter, yet we observe how it keeps galaxies from falling apart. We cannot touch dark energy yet. We feel the expansion of the universe. In our inner world, it is much the same. There are things we do not remember clearly or understand fully, yet they still shape how we love, how we fear, how we continue to live. Perhaps this is why the search for new forces in nature carries such a peculiar quality, both scientific and philosophical. It reminds us that understanding is not a fortified structure, but an open journey where each honest answer often leads to deeper, quieter questions. Albert Einstein once wrote in Ideas and Opinions, "The most beautiful thing we can experience is the mysterious. It is the source of all true art and science." Perhaps it is this sense of not knowing everything that keeps science alive and humanity humble. For if the universe were truly explained in full, there would be no room left for wonder, for contemplation, for those long nights of looking up at the sky while feeling both small and strangely at peace. Experiments at particle accelerators like the LHC are not merely collisions of matter. On another level, they are collisions between certainty and doubt. We recreate conditions close to the universe's earliest moments, not to prove that we understand everything, but to accept that we may have missed something. And within that acceptance, there is a gentle kind of beauty. It is like allowing yourself not to immediately understand your own emotions, not needing to label every thought, not rushing to heal, simply recognizing that there are forces at work in the universe and within you, even if you cannot yet name them. Philosophy has long been familiar with this feeling. Socrates left behind a simple yet enduring reminder: I know that I know nothing. Not as a statement of despair, but as an open space, a place where the mind can rest from the illusion that it must always be in control. When modern science stands before the possibility of undiscovered forces, it quietly returns to the same point as ancient philosophy: humility before the unknown. And perhaps for someone listening in the night, this carries a different meaning. It whispers that you do not need to understand your entire life right now. You do not need to explain every exhaustion, every anxiety, every question of meaning. Like the universe itself, your mind may also be operating under forces you cannot yet see, and that does not mean you are lost. Carl Jung once wrote in Memories, Dreams, Reflections, "Who looks outside dreams, who looks inside awakes." But sometimes before awakening, we must be allowed to rest, to release ourselves into uncertainty without trying to fix it. So when this story begins with the search for new forces in nature, it does not merely open a scientific question. It opens a very gentle space where the unknown is no longer a threat, but an invitation. An invitation to listen, to slow down, to trust that deeper orders are quietly holding the universe and you upright even when you cannot see them. And in that stillness, if your eyes slowly close, that is perfectly all right. After gently touching the question of whether unseen forces may still exist, the mind naturally reaches for what feels more familiar foundations that science has named, measured, and trusted for centuries. And so the slow journey of this night returns us to the four fundamental forces of nature, not to memorize them, not to study them, but to listen to them as ancient breaths of the universe, breaths that continue quietly even while we sleep. The first and most familiar is gravity. It is strange that the weakest of the four forces is the one that shapes the largest structures. Gravity is not loud. It does not strike. It simply pulls very slowly, very steadily across immense distances. It is this patience that keeps planets circling their stars, that holds galaxies together, that bends even light as it passes massive bodies. Gravity is like an aged hand, unhurried, unconcerned with proving its strength, yet always present. In human life, there are forces like this as well. Distant memories, invisible bonds, things no longer clearly present, yet still quietly pulling us in certain directions. Marcus Aurelius once wrote in Meditations, "Very little is needed to make a happy life. It is all within yourself and your way of thinking." Perhaps the gravity of the soul is made of what we carry without naming it, holding us from drifting away even when it sometimes feels heavy. From gravity's stillness, the story moves to a more vibrant force, electromagnetism. If gravity is patience, electromagnetism is vibration. It is present in the light you see, in the heartbeat you feel, in every chemical bond that forms your body. Without electromagnetism, there would be no stable atoms, no molecules, no color, no sound. This is the force of connection, where charged particles attract and repel, creating the rich diversity of the material world. There is something deeply human here. Our lives, too, are woven from invisible attractions and repulsions. We are drawn to a voice, pushed away by a painful memory. We seek balance between closeness and distance, between connection and protection. Friedrich Nietzsche once whispered in "Thus spoke Zarathustra," and those who were seen dancing were thought to be insane by those who could not hear the music. The electromagnetism of the mind may be that silent music. Not everyone hears it, yet it determines how we move through the world. Then, as the rhythm softens, we arrive at the weak force. The name sounds fragile, yet without it the sun could not shine. The weak force governs subtle transformations within the nucleus, quiet decays processes that allow energy to be released and spread. It does not build large structures, it does not bind matter together, but it allows change to happen. Perhaps this is the most human force of all. Within us, too, are such weak forces, tiny moments when we release an old belief, when a fear dissolves, when one version of ourselves quietly ends, so another can be born. Dostoevsky once wrote in The Brothers Karamazov, "The mystery of human existence lies not in just staying alive, but in finding something to live for." The weak force of the inner world is made of these silent decays, painful yet necessary. And finally, at the deepest level, there is the strong force, so powerful that it holds protons and neutrons together, despite the intense repulsion of positive charge. Without it, nuclei would fly apart and matter itself could not exist. This is the force of absolute binding, of loyalty so intense it borders on violence. It does not compromise. It allows no distance. In the human soul, the strong force may be felt as core values, things we cling to so tightly we cannot let go. Beliefs, love, pain. They keep us intact, yet sometimes make us rigid. Carl Jung once warned in Psychological Types, "What you resist persists." Even the strongest forces, when unrecognized, can become a burden. And when all four forces coexist, none unnecessary, none sufficient on its own, the universe becomes stable, diverse, and alive. Not through absolute power, but through a delicate balance between pull and push binding and decay, stability, and change. Perhaps as we listen to the story of nature's forces in the night, what remains is not knowledge, but something gentler, the sense that we too are formed by such forces. And like the universe, we do not need to understand them all in order to rest. Now, as these rhythms begin to merge, the story may drift more lightly toward deeper layers of reality. But if in this moment your mind has begun to grow quiet, that is not distraction. It is a sign that you have arrived exactly where you need to be. After listening to the quiet rhythms that hold the universe in balance, the story of this night naturally begins to drift backward, not to find a precise beginning, but to touch the way humanity has learned to see the universe over time. For the history of natural forces is not only the history of science, but also the history of human consciousness, as it slowly expanded and then learned humility before the unknown. In ancient civilizations, the sky was not an empty space. It was the dwelling place of gods, of sacred order, of eternal cycles. Humans observed the stars with the naked eye, and with a deeply human need, the search for meaning. The universe did not need to be explained through forces. It was told through stories. And perhaps it was this act of storytelling that gave people a very ancient sense of comfort that the world, however vast, still possessed order. But as with every journey toward maturity, that comfort began to fracture. The Copernican revolution did not merely move Earth out of the center of the universe. It moved the human ego out of a privileged position. When the sun was placed at the center, what was shaken was not only an astronomical model, but the feeling that humanity was the anchor of all things. And in the space that opened up a new silence emerged the silence of a universe indifferent to us. Galileo lifted his telescope toward the sky, and what he saw were no longer symbols, but details. The moon bore scars. Jupiter had moons. The perfect order of the heavens began to show signs of something almost ordinary. Johannes Kepler, with a patience close to meditation, accepted that planetary orbits were not perfect circles, but ellipses, slightly distorted, slightly off-center, yet true. There is a strange beauty in that moment when humanity learned to love imperfection in nature. From these observations, Isaac Newton appeared like a bridge. He did not merely propose gravity, he offered a language through which the universe could speak about itself. Gravity in Newton's world was an invisible yet precise force, calculable, predictable, applicable from a falling apple to the motion of planets. The world became more understandable and therefore more controllable. But alongside that clarity, a gentle illusion formed that if we knew enough formulas, we would know everything. William Blake once warned in Auguries of Innocence to see a world in a grain of sand and a heaven in a wild flower. Perhaps within Newton's precision, humanity briefly forgot how to look at the world with wonder. Then James Clerk Maxwell arrived and the voice of physics shifted again. Electricity and magnetism, once thought separate, merged into a single structure. Light was no longer mysterious. It became a wave. Space itself began to vibrate. And at the same time, a new idea slipped into human thought that things appearing separate may at a deeper level be one. There is something profoundly philosophical in this unification, as if the world continually invites us to look deeper rather than merely look more. Yet just as everything seemed to be converging toward a complete picture, Albert Einstein gently dismantled the frame. Gravity was no longer a force acting at a distance. It became the curvature of space-time. Time was no longer absolute. Space was no longer fixed. Everything grew relative softer, more flexible. The universe did not merely exist. It bent itself around mass and energy. Einstein once wrote in Relativity the Special and the General Theory, "The distinction between past, present, and future is only a stubbornly persistent delusion." This sentence speaks not only of physics, but of how humans experience life, where memory, presence, and expectation weave together into a continuous flow. And then, just as humanity believed it had gone far enough, quantum mechanics opened another door, smaller, deeper, and stranger. Their particles no longer simply are. They are here and there. They remain connected across distance. Probability replaces certainty. Observation is no longer neutral. It participates in reality. Werner Heisenberg once wrote in Physics and Philosophy, "What we observe is not nature itself, but nature exposed to our method of questioning." The line reads like a whisper in the night that reality and consciousness are not entirely separate. Here, the current of intellectual history slows, not because it ends, but because it opens in too many directions at once. From the perfect circles of antiquity to Kepler's gently distorted orbits, to Einstein's curved space-time. And finally, to the hazy probabilities of the quantum world, each step forward adds knowledge, but also takes away a certainty. Perhaps this is science's quiet gift. It does not lull us with answers, but with permission not to know everything. And in the night, as you listen to this story, you do not need to remember any names or formulas. You only need to sense that the journey of understanding the universe is much like the journey of understanding yourself. The deeper you go, the more layers appear, and the more gently you learn to approach what remains unclear. From here, the current may continue to flow toward experiments, observations, and questions without answers. But if right now your mind begins to loosen its grip, that is not losing your way. It is how the universe and its history gently sings you into sleep. When the current of intellectual history has carried us through great turning points, from the symbol-filled skies of antiquity to Einstein's curved space-time, and then into the hazy world of quantum mechanics, the mind may naturally wish to go deeper still. Not upward, but inward. Not toward vast orbits, but toward the smallest movements. And at that depth, particle physics appears as a very soft whisper, yet one that carries the weight of the entire universe. Here, humanity no longer gazes at planets, but at fragments of reality itself, particles so unimaginably small, yet decisive for everything you are feeling right now. The weight of your body, the warmth on your skin, the light touching your half-closed eyelids. Particle physics does not seek grandeur, it seeks structure. And within that structure, a remarkably subtle order begins to reveal itself. Enrico Fermi was among the first to accept that at its deepest level, nature does not operate according to ordinary intuition. Weak decays, tiny transformations within the nucleus may appear random, yet they obey discrete laws. Later, Steven Weinberg and Abdus Salam continued along this path, not by adding new forces, but by looking more deeply into the relationships among those already known. Electromagnetism and the weak force, once thought distinct, emerged as two expressions of a single foundation. The electroweak theory appeared not only as a mathematical achievement, but as a gentle reminder at its deepest layers the world tends toward unity. There is something quietly healing in this idea. In our inner lives too, we often feel divided reason set against emotion, desire, and conflict with duty, light, and shadow pulling in opposite directions. Yet particle physics whispers that what seems separate may be nothing more than different perspectives on the same reality. Carl Jung once wrote in Psychology and Alchemy, "The meeting of two personalities is like the contact of two chemical substances. If there is any reaction, both are transformed." Perhaps at the deepest level, both nature and the human being are governed by such silent reactions. From this unity, the story drifts toward another force, stronger, harsher, the strong force. Hideki Yukawa once imagined that there must be a mediator particle to hold nucleons together, a simple hypothesis, yet one that opened an entire world. Later, with the work of David Gross and Frank Wilczek, the strong force ceased to be a blunt interaction and became a refined network of quarks and gluons described by quantum chromodynamics. Their particles never stand still. They are bound within an endless dance. Perhaps the strong force is the most paradoxical of all. It is so powerful that it allows no distance, yet for that very reason quarks are never observed alone. They exist only in relationship. This sounds deeply familiar. Humans too are strongest when we belong, when we are connected, when we are held within some structure. Yet that very binding can also prevent us from ever standing entirely on our own. Friedrich Nietzsche once wrote in Beyond Good and Evil, "He who fights with monsters should be careful lest he thereby become a monster." Even the strongest forces, when not understood, can bind the very thing they are meant to protect. And then, after decades of building theory, a profoundly human question arises. If particles interact, if forces exist, what gives them mass? Why are some particles heavy and others light? Why is the universe not merely light passing through itself? The Higgs boson emerges as a remarkably quiet answer, not loud, not intuitive. An invisible background field spread throughout space that causes particles to feel heavy. Mass is no longer an inherent essence, it is the result of interaction. There is a deep beauty in this, for it tells us that nothing is entirely self-contained. Even your weight, both physical and emotional, arises from relationship, as Simone Weil once wrote in Gravity and Grace. Grace fills empty spaces, but it can only enter where there is a void to receive it. Perhaps the weight of a life is formed in the same way from invisible fields we do not recognize yet, which are always present. When the Higgs boson was finally discovered, it was not met with triumphant cheers, but with a long exhale of relief. Not because everything was finished, but because one more piece had clicked into place. And still, the picture remained incomplete. Gravity stood apart. Dark matter and dark energy stayed silent. And at the deepest level, particle physics did not offer absolute certainty, but something far more delicate, the sense that reality is woven from subtle interactions, not from rigid bricks. Here, the current of the story does not break. From intellectual history, we move into structure. From structure, we touch fragility. And from that fragility, we arrive at a gentle realization. Understanding is not meant to control the universe, but to live in harmony with it. As you listen to stories of scientists, of particles, of forces, you may not need to remember their names. It is enough to feel that at its deepest level, the universe is not loud. It whispers. It connects. It holds and releases at the same time. And if in this moment your eyelids begin to grow heavy, if concepts dissolve into sensation, that does not mean you are missing anything. Perhaps you are touching exactly the way the universe and your own mind wishes to be heard, very slowly, very deeply and lightly enough to drift into sleep. As the night's journey carries us beyond the delicate structures of particle physics, the mind may begin to feel a faint sense of unsteadiness. Not because these ideas are too complex, but because they quietly unsettle our familiar intuition about how the world should behave. And it is precisely at this point of gentle imbalance that quantum mechanics enters, not as an answer, but as a whisper that softens, blurs, and deepens every concept we thought we understood. In the quantum world, nothing stands still long enough to be simply observed. A particle can exist in multiple states at once, as if it has not yet decided who it is until it is seen. Superposition is not merely a physical term. It mirrors the state of the human mind before it is forced to choose. We are both strong and fragile, both wanting to move forward and wanting to stop. And perhaps we only collapse into a single definite state when life compels us to name one. Then comes entanglement, the strange binding of particles that once touched such that no matter how far apart they are separated, they continue to respond to one another as if they were one. No signal travels, no time passes, only a connection that transcends distance. This idea unsettled Einstein. He called it spooky action at a distance. Yet to the human soul, it sounds strangely familiar. There are bonds that require no explanation. People who have long since left us, yet a single memory is enough to make the heart tremble. Moments from the past still quietly shaping the present, as though time never truly severed them. When Werner Heisenberg spoke of the uncertainty principle, he touched a deeply human limit. We cannot know everything precisely at the same time. Not because we lack skill, but because the nature of reality itself does not allow it. In Physics and Philosophy, he wrote, "What we observe is not nature itself, but nature exposed to our method of questioning." The line reads like a quiet lullaby, that the world is not hiding from us, but that we may still be asking it the wrong kinds of questions. Quantum mechanics also reshapes the way we understand forces. Instead of abstract pulls and pushes acting across distance, we speak of force carrying particles, photons for electromagnetism, gluons for the strong force W, and Xi bosons for the weak force. Interactions become exchanges, fleeting moments of contact, brief, rapid, yet full of consequence. Reality is woven from these instantaneous meetings. There is something deeply comforting in this view, for it suggests that the world does not operate through rigid commands, but through relationships. Nothing happens in isolation. Everything is interaction. Martin Buber once wrote, "In I and thou, all real living is meeting." Perhaps at the deepest level, both physics and life agree on this. And yet within this seemingly ever more complete picture, a quiet gap appears. Gravity, the force that has guided human thought for centuries, has no confirmed force-carrying particle, no graviton in hand, no way to bring gravity fully into the same language as the other forces. And so quantum mechanics, so successful in so many realms, encounters the boundary of its own reach. This gap is not loud. It does not collapse the theory. It simply remains silent, like a question left unfinished. And within that silence, we recognize something essential. Even the most powerful theories are not immune to incompleteness. Perhaps this is not failure, but an invitation to keep listening. Philosophy has long been familiar with this feeling. Soren Kierkegaard once wrote in concluding unscientific postscript, "Life is not a problem to be solved, but a reality to be experienced." In its own way, quantum mechanics seems to say the same about the universe. It does not ask us to control reality, but invites us to experience it with humility. And while gravity remains outside the quantum frame, the question is no longer only how to unify the forces, but whether our way of seeing is gentle enough to hold a more complex reality. Perhaps like the human mind, the universe cannot be forced into a single system without losing something subtle and essential. At this point in the journey, the flow of thought does not break. From particle physics, we move into uncertainty. From uncertainty, we learn to accept the empty spaces. And from those spaces, something very gentle arises, the realization that not everything must be clear in order for us to rest. If you are listening in the night, you do not need to understand what superposition truly means or how entanglement works. It is enough to feel that this world, both outside and within, is more complex than anything we can fully name. And that does not make it less safe. On the contrary, it allows us to soften. Whispering particles, exchanged forces, unanswered gaps, all existing together, unhurried, unclosed. And if in this moment your thoughts begin to dissolve into a vague yet pleasant sensation that is not distraction, it is the moment when quantum mechanics and perhaps life itself is doing the gentlest thing it can, allowing you to rest within uncertainty, and from there, to drift very slowly into sleep. After quantum mechanics taught us to accept uncertainty, and gravity continued to stand quietly outside every attempt at quantization, the current of thought naturally turns toward a very old longing, one that has never lost its quiet pull: unity. Not unity for the sake of control, but unity for the sake of understanding. Not to close questions, but to listen for whether the scattered fragments of reality might blend into a deeper harmony. At the crossroads of this longing string, theory appears not loudly, not intuitively, but like a piece of very soft music. In this view, what we call particles are no longer rigid points, but vibrating strings. Each vibration is a different note, each note a particle, and each particle a way the universe speaks about itself. Space, then, is not limited to the three familiar dimensions. It may fold, curl, and hide within dimensions so small that we have never touched them. There is a gentle comfort in this idea, for it suggests that the world's diversity does not arise from division, but from rhythm. Like music, many notes, one song, many motions, one harmony. Plato once wrote in Timaeus, "Music is a moral law. It gives soul to the universe, wings to the mind, flight to the imagination." String theory, in a sense, invites us to hear the universe as music. Not something to see, but something to feel. Yet not everyone chooses to listen through strings. Some listen through structure. Loop quantum gravity enters the story as another whisper. Space-time is not infinitely smooth, but woven from very small units like the pixels of reality. Here, space is not a fixed stage on which everything happens. It is formed moment by moment from quantum loops. There is a quiet beauty in this idea. It tells us that even what seems most continuous space and time is made from discrete pieces. And if that is so, then discontinuity is no longer a flaw. It is structure. In our inner lives, too, we often wish for seamlessness, memory linking to memory, goal to goal. Yet the mind is woven from separate moments, and it is precisely this that allows it to breathe. Ludwig Wittgenstein once wrote in Tractatus Logico-Philosophicus, "The world is everything that is the case." If space-time is woven from fragments, then the world does not need to be seamless in order to be. It only needs to be present exactly as it is. And then, on another level where energies grow so high that differences begin to dissolve, grand unified theories raise their voice. The idea is simple, and therefore bold. At a very early moment in the universe, when everything was hot and dense, the forces were not separate. They were one. Only as the universe cooled did they branch like a great river, dividing into smaller streams. There is something deeply human in this image, for human life too begins in unity of potential, of desire, of undivided possibility. As time passes, we learn to name things: reason, emotion, responsibility, longing. Differentiation allows us to survive. Yet sometimes, in very quiet nights, we remember the feeling of being one without roles, without choices. Baruch Spinoza once wrote in Ethics, "All things excellent are as difficult as they are rare." Unity, perhaps, is that rare thing, not because it is distant, but because it requires the patience to pass through every fragment. What matters is this: none of these three paths, vibrating strings, quantum space-time, or high-energy unification, has been fully confirmed. They exist side by side like different dreams of the same reality. And instead of calling this failure, modern science is learning something very gentle. Perhaps reality is wide enough to hold many ways of telling its story. Here, the flow of thought naturally meets philosophy. William James once wrote in The Will to Believe, "The deepest problems of life are never solved but only outgrown." Perhaps the search for unity is not meant to solve the universe, but to allow humanity to grow alongside its questions. And if you are listening in the night, you may feel the familiarity of this longing. The wish that the contradictions within you, strength and weakness, light and shadow, certainty and uncertainty, might somewhere come together. without force, without haste, simply with the trust that there is a deeper layer where separation is no longer necessary. At that depth, string theory whispers of rhythm, loop quantum gravity whispers of structure, grand unification whispers of a common origin. Three different voices, yet not opposed. They are like three lullabies, each touching a different part of the mind. And as the story slows, as concepts soften into sensation, you may not need to remember the name of any theory. It is enough to feel this. Even science at the height of its effort is learning to speak more softly, no longer making absolute declarations, only extending invitations. An invitation to see the world as an unfinished piece of music, an invitation to accept fragments as natural structure, an invitation to trust that somewhere very deep, everything once was one and may still be one. And if in this moment your thoughts feel lighter, if questions no longer demand answers, then perhaps you are touching what every unifying theory ultimately points toward: not certainty, but peace. When attempts to unify theories begin to reach the limits of pure reasoning, the story of this night gently changes direction from inward to outward. No longer only equations on paper or models imagined in silence, but the human gaze cast far into the sky. And there, within slow and patient astronomical observation, the universe begins to whisper mysteries that the four familiar forces cannot yet answer. Galaxies rotate, but they rotate too fast. According to what familiar gravity allows, the stars at the edges of galaxies should have flown apart, drifting away into darkness. Yet they do not. They remain as if an invisible hand were holding them together. Dark matter emerges not as something seen, but as an absence with weight. We do not see it, but we see what it does. And in that quiet presence, the universe offers a gentle lesson. Some things exist without needing to appear. In the inner life, there are forces like this as well. Memories no longer sharp, sorrows without names. They do not present themselves yet. They hold our structure intact, or sometimes pull us in directions we do not understand. Blaise Pascal once wrote in Pensée, "The heart has its reasons, which reason knows not. Perhaps the dark matter of the soul is made of these silent reasons." And then, just as humanity thought the universe was expanding, only by its initial momentum, observations whispered something else: the expansion is accelerating. Space is not merely opening, it is opening faster over time. Dark energy appears as a temporary name for something deeper, a gentle, steady push present everywhere. It does not tear structures apart all at once. It patiently increases the distance between all things. There is a faint sadness in this image. It suggests that over time the universe will grow colder and thinner. Yet it also carries a strange comfort. Space continues to allow everything room to move. In the human mind, too, there are periods when everything seems farther apart. Emotions, people, dreams. And sometimes that expansion is necessary, so we are not suffocated by what we once clung to too tightly. Then come gravitational waves, tiny ripples in the fabric of space-time born from violent events such as the collision of black holes. They carry no images, no colors, only rhythm. And when humanity finally heard them, what was confirmed was not only Einstein's prediction, but a deeper feeling: space-time is not rigid. It can vibrate. There are disturbances in life like this as well. No one sees them yet. We feel their effects: subtle changes in how we stand, how we breathe, how we look at the world. Soren Kierkegaard once wrote in The Concept of Anxiety, "Anxiety is the dizziness of freedom." These invisible vibrations, whether from the cosmos or from within, remind us that stability is not immobility, but the ability to vibrate without breaking. Deeper still, the cosmic microwave background. The oldest surviving light quietly blankets the entire sky. It carries the universe's memory from when it was very young, very hot, very dense. Not a sharp image, but a soft, even echo, almost lulling. In it, humanity sees not only data, but traces of a beginning. There is something deeply healing in knowing that the universe, too, has memory, that even this vast reality carries marks of its childhood. And like humans, the universe does not need to remember every detail precisely in order to continue. It only needs to carry a very deep, very quiet foundation. Then come cosmic rays, high-energy particles from distant space, sometimes bearing anomalies that resist explanation. Positron excesses, neutrino irregularities, small, rare, uncertain signals. Yet it is precisely this uncertainty that makes scientists listen more carefully. For sometimes, the most important things arrive not as loud declarations, but as slight deviations. William James once wrote, "In the varieties of religious experience, the deepest principle in human nature is the craving to be appreciated." Perhaps the universe too longs to be heard in this way, not through what fits perfectly into models, but through where it drifts ever so slightly out of line. And when we gather all these observations, dark matter, dark energy, gravitational waves, ancient light, offbeat particles, a strange feeling emerges. Not confusion, but humility. The four familiar forces still hold true, but perhaps they are not enough. Perhaps other interactions are quietly at work, very subtle, very deep, still unnamed. At this point in the journey, the flow of thought does not break. From theory, we step into the sky. From the sky, we return inward. And in between, a resonance appears. Understanding does not come from forcing reality into a frame, but from allowing it to speak in its own way. If you are listening in the night, you may not need to remember which phenomenon leads to which. It is enough to feel this: the universe is not silent. It simply speaks very softly. And sometimes to hear it, we must release the need to understand immediately. These observations do not close the story. They open it. And in that opening, if your mind grows quieter, if questions soften, then perhaps you are doing the most fitting thing right now, listening to the universe and to yourself in silence. And from that silence, sleep may arrive very slowly, very gently. When astronomical observations begin to whisper of small deviations in the structure of the universe, the flow of this night naturally draws us toward extreme places where nature no longer follows familiar intuition and every concept softens, bends, or even dissolves. At these edges, the universe does not speak louder, it speaks deeper. And it is precisely there that the question of new forces begins to take shape. Black holes appear not as ordinary objects but as boundaries. The event horizon is not a wall but a threshold where information enters and does not return. Everything that crosses this boundary seems to vanish from the story the universe tells the rest of itself. And yet the information paradox whispers that information cannot truly disappear. So where does it go? Into faint radiation onto the surface of the horizon, or into a language we have not yet learned to read? There is something deeply human in this question. In our inner lives, too, there are such horizons, memories we can no longer name, emotions compressed after upheaval, parts of ourselves that crossed a threshold and never returned in the same form. We wonder, did they truly vanish, or did they merely change place, change form, and continue to influence us in the quietest ways? Martin Heidegger once wrote in Being and Time. The nothing itself nothings. Perhaps emptiness is not absolute absence, but another mode of presence. Black holes in this sense do not merely swallow matter. They invite us to rethink how information, force, and reality are held. If black holes are places where familiar structure collapses into silence, then neutron stars are places where matter is compressed to its utmost limit. Pressure there is so immense that atoms cease to be atoms. Electrons are forced into protons, forming neutrons. Magnetic fields twist space itself. Forces no longer behave as they do in quiet laboratories. They transform, intensify, and interact in new ways. In such conditions, the standard model, so remarkably successful, begins to show its edges. Not because it is wrong, but because it is not wide enough to encompass the most extreme regimes. And it is precisely at these harsh boundaries that traces of unnamed interactions may appear new forces or new expressions of familiar ones. There is a gentle bridge between this and human life, for only when we are compressed by pressure loss responsibility do our deepest aspects begin to surface. We do not discover ourselves in absolute comfort. We recognize ourselves at the edge. Carl Jung once wrote in Psychological Types, "There is no coming to consciousness without pain." Neutron stars in this sense become symbols of awareness born from pressure. What is striking is that neither black holes nor neutron stars break nature. They amplify it. They place forces into conditions where differences become sharper. And when differences sharpen, the question of unity or of new forces no longer feels speculative but inevitable. In the night, as we speak of these extreme celestial bodies, the story does not depart from its earlier thread. From small deviations in observation, we move to nature's extremes. From extremes, we learn to listen for what does not appear under ordinary conditions. And from this listening, a warm humility emerges. Understanding is not about pulling everything toward the center, but about accepting the edges. Friedrich Nietzsche once wrote in Thus Spoke Zarathustra, "One must still have chaos in oneself to be able to give birth to a dancing star." Black holes and neutron stars carry the universe's chaos, but it is within this chaos that new structures may arise, new forces may reveal themselves, and new questions may be asked in softer voices. And if new forces exist, perhaps they are not loud. They do not announce themselves. They appear as boundary effects, as subtle deviations that only become visible when everything is pushed to its limits. This reminds us that truth is not always found at the center. Sometimes it lives at the edge. At the edge of black holes, information does not vanish. It changes how it exists. At the edge of neutron stars, forces do not disappear. They change how they interact. And at the edge of human understanding, questions do not fade. They change their tone. They grow slower, deeper, and less demanding of immediate answers. Simone Weil once wrote in Waiting for God, "Attention is the rarest and purest form of generosity." Perhaps what extreme celestial objects invite from us is precisely this attention, not rushing to explain, not forcing closure, but simply listening to what is being spoken. At the edge of what we can know. And as the night story passes through these harsh boundaries, it does not grow heavier, it grows lighter. For when we allow extremes to exist without trying to tame them, the mind no longer has to strain for control. It can soften like space-time, curving around mass, then flattening again in the distance. If you are listening in the night, you do not need to remember details about event horizons or neutron pressure. It is enough to feel this: there are parts of the universe and parts of yourself that only reveal themselves at the edge. And that is not frightening. It is real. Now, as the current continues to flow, the story may travel even farther toward new hints, new forces, unnamed interactions. But if in this moment your eyelids grow gently heavy, if concepts dissolve into sensation that is not losing your way, it is the moment when you are standing exactly where extreme celestial bodies have taught us to stand, very close to the edge, very still and safe enough to rest. As the night's journey carries us to the most extreme boundaries of the universe, where matter is compressed into silence, where space-time bends around mysteries, the current of thought gently returns to the point of origin. Not to seek a loud, explosive moment, but to listen to the stillness before everything began. There, in the early universe, the question of new forces is no longer speculation. It becomes a distant memory that science is slowly learning how to recall. The Big Bang is often told as a violent beginning, yet when we listen more slowly, we sense that it was also a fragile one. Energy at unimaginable levels, space not yet stretched open, time not yet flowing in its familiar rhythm. Under such conditions, the forces we know today may not have been separate at all. They may once have been one, or existed in forms so different that they had no names. There is a gentle beauty in this idea. It suggests that fragmentation was not the original state. It was the result of cooling of the universe, learning how to breathe more slowly. As energy diminished, the forces separated, each taking on its own role. Yet, in the deepest memory of the universe, they may still carry traces of that unity, like a piece of music that has split into many voices while still sharing a single underlying melody. Heraclitus once wrote, "Nature loves to hide." Perhaps the early universe is where nature hid its secrets most carefully, not to tease humanity, but to wait until we became patient enough to listen. In those earliest moments, inflation is spoken of as a first breath. Space expanded at extraordinary speeds, so fast that tiny quantum fluctuations were stretched outward, becoming the seeds of all later structure. Galaxies, clusters of galaxies, vast cosmic voids, all began from movements that were incredibly small, incredibly random. There is something deeply healing in this image. It tells us that the greatest things do not always begin with grand intention. Sometimes they begin with the slightest trembling. In human life, too profound change can arise from a fleeting thought. A new path can open from a vague feeling. Meaning does not require clarity at the beginning. William James once wrote in Pragmatism, "The greatest discovery of my generation is that a human being can alter his life by altering his attitudes." The quantum fluctuations of the mind, tiny shifts in how we see, can over time shape an entire life. And then, as the universe continued to cool, the Higgs field quietly entered the story. Not as a central character, but as an invisible background. The Higgs field spread throughout space, and as particles passed through it, they felt its presence and thus acquired mass. The world grew heavy, structures could form, forces began to take on more familiar shapes. There is a deep tenderness in the idea that mass is not imposed but emerges from interaction, that the weight of existence does not arise in isolation but from relationship with what surrounds us. Simone Weil once wrote in Gravity and Grace, "We have to accept the fact that we are not everything. Perhaps the Higgs field of life is the background we often forget, the quiet support that gives us just enough weight to remain." In the early universe, when the forces had not yet fully separated, the possibility of other interactions, new forces, was not strange. They may have existed, then faded as the universe changed, or they may still be present, extremely weak, revealing themselves only under special conditions. Searching for them is like listening for an old sound long covered by the noise of time. Philosophy has long been familiar with this sensibility. Edmund Husserl spoke of returning to the things themselves not to add more concepts, but to slow the gaze. In that sense, the Big Bang is not only a physical event. It is a reminder that every beginning is ambiguous when experienced from within. Only with distance does structure become visible. And as the current of thought links the sections together from extreme celestial bodies back to the early universe, a very quiet rhythm appears. At the edge of time where nothing was yet distinguished, the question of new forces carries no tension. It feels like a gentle memory that there was once a simpler state, not because it was poor, but because it did not yet require division. Perhaps in our inner lives we carry that memory as well, a primordial sense that everything was once more whole. And so the longing for unity, whether in science or in the soul, is not a wish to escape reality, but a wish to remember a deeper stillness. Martin Heidegger once wrote, "The beginning is still. For him the beginning is not loud, it is quiet." And within that quiet, every possibility remains open. If you are listening in the night, you may not need to picture the Big Bang inflation or the Higgs field with precision. It is enough to feel the universe, like the human being, was not born from certainty but from possibility. And that possibility does not require you to stay awake to understand it. It only asks you to be still enough to feel. As the story drifts slowly through the origin, through tiny fluctuations that became an entire sky, the mind may begin to lighten. Questions no longer press for answers. New forces no longer need immediate proof. They become a reminder that some things reveal themselves only when we are no longer rushing to find them. And if in this moment your thoughts dissolve into a gentle warmth, if the memory of beginnings merges with a slow breath, then perhaps you are touching what the early universe has preserved until today, a silence deep enough for everything to begin and for you very softly to drift into sleep. After quietly passing through the origin of the universe where forces once merged in silence, the flow of this night shifts into a different rhythm. No longer the distant memory of the Big Bang, but the very human efforts of the present hands machines and patient eyes searching for forces that nature has not yet agreed to name. Here, technology no longer wears the loud face of progress. It becomes a form of modern meditation, listening to the universe with the most refined instruments in deep and attentive patience. Particle accelerators such as the Large Hadron Collider are often described as colossal machines where particles are smashed at near light speed. But when we slow the view, they resemble a curious ritual. Humanity recreates moments close to the universe's infancy, not to destroy, but to ask again. Each collision is a question. Each trace of data is a whisper. Is there something beyond the four familiar forces? In philosophy, Martin Heidegger once reminded us that technology is not merely a tool, but a way in which humanity reveals the world. In the question concerning technology, he wrote, "The essence of technology is by no means anything technological. At the deepest level, accelerators are not just steel and magnets. They are expressions of the longing to understand, a longing that is quiet and enduring. Beyond the vast tunnels, the search for new forces becomes smaller, still unfolding within ultra-sensitive detectors and quantum sensors. These devices do not seek loud signals. They listen for deviations so slight they almost do not exist. Vibrations softer than a whisper changes, subtler than a passing thought. There is something quietly healing in realizing that the deeper science moves into reality, the lighter its touch becomes." This recalls Blaise Pascal's words in Pensée. All of humanity's problems stem from man's inability to sit quietly in a room alone. Quantum sensors, in a sense, have learned this lesson. They remain still long enough for the world to reveal itself. And then there are experiments that require no enormous machines at all. Tabletop quantum experiments unfold on small laboratory benches in quiet rooms. Atoms are cooled to near absolute zero. Light is guided to measure the most delicate effects. The quantum world appears not as a storm, but as a lake where even a single ripple carries meaning. Here lies a gentle paradox. To reach the deepest forces of nature, humanity does not need more power, but more stillness. Greater precision demands greater quiet. Greater sensitivity requires less interference. This is close to the spirit of meditation, where understanding arises not through force, but through sustained observation. From Earth, the gaze is lifted again by satellite missions. Gaia measures the motion of billions of stars, as if redrawing the galaxy's invisible gravitational map. Planck listens to the cosmic microwave background, the faint echo of the early universe. And in the future, Lisa will listen for gravitational waves from space, where the vibration of space-time becomes distant music. These satellites do not see in the usual way. They listen, they feel, and within that listening, small anomalies, departures from expected models become precious. For it is in these slight mismatches that the possibility of new forces begins to appear like an incomplete memory. Carl Jung once wrote in Memories, Dreams, Reflections, "Who looks outside dreams, who looks inside awakes." Satellites look outward, yet they also help humanity awaken to the limits of its own understanding. Each data point that fails to fit is an invitation to humility. And in our time, a new listener joins the journey AI. It does not sleep, it does not tire. It carries no emotional expectation. AI does not search for new forces through intuition, but through the ability to recognize patterns too subtle for human perception. It sifts through mountains of data, finding the smallest deviations, the correlations no one thought to look for. This may sound cold, yet at a deeper level, AI reflects an ancient dream understanding without imposition. Spinoza once wrote in Ethics, "The more we understand individual things, the more we understand God." AI does not understand in a human sense, but it expands the space in which humanity can understand more deeply and more slowly itself and the universe. Amid all these technologies, a very delicate thread connects every part of the journey. From the Big Bang to accelerators, from quantum fluctuations to satellites listening to space-time. It is a shift from seeking grand answers to attending to small signs, a maturation of awareness. In our inner lives, we pass through a similar movement. At first, we search for large explanations for our exhaustion. Gradually, we realize that healing does not come from monumental answers, but from noticing small changes, a slower breath, a softer thought, a moment of quiet. In this light, technology does not oppose philosophy. It becomes a form of experimental philosophy where the essential question is no longer, what can we do, but what can we notice? And as the narration drifts past, machines, satellites, and algorithms, the voice of the night grows gentler. New forces, if they exist, may not wish to be chased. They wish to be recognized like a deep thought not yet formed into words, like a calm sensation not yet named. If you are listening now, you may not need to remember the LHC Gaia or Lisa. It is enough to feel this: the world from the cosmos to the mind is being explored in a new way, quieter, more attentive. And within that listening, not only new forces may appear, but a sense of ease begins to form. And so very softly, as technology fades into the background of a slow rhythm, as questions no longer press, you may let your mind drift in time with the universe, slowly, deeply, and calm enough to fall into sleep. As the night's current carries us past laboratories, silent satellites, and sleepless algorithms, a new question begins to surface. Not whether new forces exist, but what might happen if one day humanity were to truly touch them. Yet here, we do not rush toward the future as a technological explosion. We move more slowly, more gently. For every great discovery before becoming an application was once a fragile idea, like a tender thought arising in the mind at midnight. If a new force were discovered, the first thing science would dream of is not power, but stability. For decades, quantum computing has faced a paradox: nearly limitless potential, yet so delicate that a single disturbance can cause everything to collapse. A new force, if it exists, could become a quiet foundation where quantum states are held steady, like an even breath in meditation. Not to make machines smarter, but to make the world less chaotic. There is something deeply familiar in this longing. Marcus Aurelius once wrote in Meditations, "You have power over your mind, not outside events. Realize this and you will find strength." Stable quantum computing at its core is also an attempt to reclaim agency amid disturbance, not only in particles but in modern life itself. From there, the dream of new materials comes into view. Materials that can alter their properties on demand: rigid when support is needed, soft when protection is required, conductive or insulating with the faintest signal. Yet if we listen closely, this is not merely a technical story. It is a dream of adaptive existence, of flexibility without the loss of essence, like a human learning to be strong without becoming rigid, gentle without dissolving. Heraclitus once said, "No man ever steps in the same river twice." The materials of the future may live by that spirit, always changing yet not chaotic, always adapting yet retaining a deep structure. Then comes the greatest and most unsettling dream energy. A new force could open pathways to forms of energy that are extraordinarily clean, perhaps even nearly limitless. But in the night's narration, what matters is not limitless, but non-destructive. For the first time in history, humanity might no longer have to trade life for power. No burning, no extraction to exhaustion. Here, philosophy steps in with a gentle reminder. Hannah Arendt warned in The Human Condition that technological power, when separated from ethical reflection, can lead humanity astray. A new force, therefore, is not only a problem of physics, but a test of humanity's inner maturity. Are we ready to wield power without losing humility? The flow of thought drifts lightly toward a more distant horizon, advanced propulsion systems. New forms of propulsion, no longer constrained by traditional fuels, could open the way to interstellar travel. Yet when heard with a slower heart, this dream is not merely about going farther in space, but about escaping haste in time. Interstellar travel would no longer be a race, but a journey slow enough for humanity not to lose itself among the stars. Carl Sagan once wrote in Pale Blue Dot, "The universe is a pretty big place. If it's just us, seems like an awful waste of space." But perhaps before asking whether the universe is wasteful, we should ask whether we are wasting our own awareness along the path of exploration. And then in the deepest silence, a new force, if discovered, may reach the most delicate domain medicine at the atomic level. No longer healing through confrontation, but through subtle adjustment. Cells are listened to. Molecules are understood. Healing becomes not a battle, but a gentle dialogue with the body. This recalls Baruch Spinoza's words in Ethics. The mind and the body are one and the same thing, conceived now under the attribute of thought, now under the attribute of extension. Future medicine supported by deeper forces may simply be returning to a very old truth. Body and mind were never separate. Seen from afar, these applications appear as peaks of progress. But in the night's lullaby-like voice, they are arranged as possibilities, not promises, not destiny. Each possibility carries a quiet question. Will we use it to control or to understand, to dominate or to harmonize? Here the flow between the sections does not break. From the search for new forces, we moved through technology, touched ethics, and returned inward. For every external application ultimately reflects an inner state. The more refined technology becomes, the more slowly consciousness must move. If you are listening at this moment, you may not need to remember every application, every potential. It is enough to feel this. The future does not have to be loud. A new force, if it appears, does not need to make the world move faster. It may help the world breathe more evenly. And like sleep itself, the deepest progress does not come from intense stimulation, but from a safety spacious enough to let go. When the mind no longer strains to keep up with the future, it begins to settle. Light, slow, warm. Perhaps the most important application of any new force is helping humanity relearn how to rest within itself, while the universe continues to expand very far, very quietly, and very gently. As the night's journey carries us beyond the potential applications of a force yet unnamed, the current of thought gently turns toward a deeper direction, not what we might do with such a force, but what we may need to rethink about the very foundations of our understanding. Here, science does not advance with the noise of breakthrough, but with the quiet of a structure on the verge of being rewritten. Like a familiar room in which one wall is suddenly discovered to have existed only in imagination. The standard model of particle physics has long served as a map precise enough to keep humanity from losing its way in the microscopic world. It describes particles' interactions and laws with near-perfect accuracy. But if a new force truly exists, that map is no longer the end. It becomes a chapter important and beautiful, yet incomplete. And in this quiet night, the idea of extending or even replacing the standard model does not feel destructive, but like a natural maturation of awareness. Thomas Kuhn once wrote in The Structure of Scientific Revolutions, "Paradigm shifts do not come from adding new facts to old frameworks, but from changing the frameworks themselves." Such changes are rarely loud from within. They begin with a subtle sense of mismatch, very small, between what we observe and what we believe we understand. If the standard model is expanded, this does not simply mean adding a few more particles to an already long list. It means accepting that reality has more layers of interaction than we once imagined. New forces, new particles, new mechanisms would need to be described not only with mathematics, but with a conceptual language gentle enough not to distort what is unfamiliar. And this closely resembles the inner process humans undergo when entering a new phase of life, not rejecting the past, but widening it. At a deeper level, the emergence of new interactions forces us to ask again, what is the true foundation of reality? Are forces independent entities or merely different expressions of a deeper structure? This question is not foreign to philosophy. Spinoza suggested in Ethics that reality has only one substance and that all diversity is simply different modes of expression of the same foundation. Science, perhaps, is moving very slowly toward a similar intuition, but by experimental means. And amid all these changes, gravity still stands there like a familiar figure that never quite fit in. Within the standard model, gravity has no natural place. It is described elsewhere in a different language, curved space-time geometry continuity. If a new force appears, the quantization of gravity no longer feels like a distant dream, but a logical necessity. Not to conquer gravity, but to converse with it in the same language we use for the other forces. Here, the quantization of gravity does not appear as a dry technical problem. It becomes a deeply philosophical moment. For the first time, humanity attempts to describe space and time themselves, the frameworks of all experience as entities with structure, vibration, and limits. Time is no longer merely a flow. It may be made of beats. Space is no longer infinitely smooth. It may consist of extraordinarily subtle points. Martin Heidegger once wrote, "In being and time, time is not a thing, thus nothing which is, and yet it remains constant in its passing away without being something temporal like a being and time." In a sense, quantizing gravity is science beginning to touch the question philosophy has long whispered. What is time if not a thing? The flow between sections here does not break. From technological applications, we move to theoretical foundations. From those foundations, we touch the nature of space-time itself. And from there, we return to lived experience, the feeling of stability, of order, of trust, that the world can be understood even if never completely. If the standard model is replaced, this would not mark the collapse of science, but its humility. At its most beautiful, science is not a closed system, but a process of self-correction, much like the human mind learning to release beliefs that no longer support it. Carl Jung once wrote in Modern Man, In Search of a Soul, "The shoe that fits one person pinches another. There is no recipe for living that suits all cases." Perhaps there is no single physical model that fits every layer of reality either. Each model is a pair of shoes good enough for a stretch of the journey, then needing replacement as the path continues. And in the lullaby-like voice of the night, this brings no anxiety. On the contrary, it offers a gentle reassurance one does not need to hold a complete picture in order to rest. The world may still be rewriting itself somewhere within equations, but right now we can rest in the knowledge that incompleteness does not mean the absence of meaning. New particles, new forces, unnamed interactions all simply remind us that reality is wider than what we carry in our minds. And when we allow our maps to change, the mind itself is freed from the burden of having to understand everything. If you are listening and feel your thoughts slowing, that is not a sign of exhaustion. It is a sign of trust. The trust that you do not need to grip every concept tightly in order to exist safely within this universe. The standard model may expand. Gravity may be quantized. Deeper structures may slowly reveal themselves. But tonight, what matters most is not which model is correct, but this very human feeling that you are allowed to loosen your grip a little, to let space-time continue to flow, and to allow sleep to arrive as a gentle conclusion to every question not yet answered. When the night's journey has carried us to the edge of familiar physical models, where equations begin to tremble as they try to hold what has never yet been named, another layer of questioning quietly emerges. No longer the questions of the laboratory, but the questions of meaning. When a new force appears or is even merely suspected, science does not only extend the frontier of knowledge, it compels us to look again at how we understand truth, causality, and humanity's place in the universe. First comes the idea of scientific truth. In common intuition, truth is often imagined as a fixed destination, right or wrong, existing or not existing. Yet the history of science tells a gentler story. Truths once considered absolute separate space and time, linear causality, a static universe, have all been rewritten, not because they were false, but because they were not yet deep enough. Karl Popper emphasized that science advances not by proving itself eternally correct, but by accepting the possibility of being wrong. In The Logic of Scientific Discovery, he wrote, "Our knowledge can only be finite, while our ignorance must necessarily be infinite." If a new force appears, it does not negate what we know. It simply reminds us that scientific truth is always provisional, like a lamp that lights the path ahead, bright enough for the present stretch, but never illuminating the entire road. From here, the notion of causality begins to soften as well. In the classical world, every event has a clear cause that precedes it and leads to a result that follows. But quantum mechanics has already unsettled that order. And if a new force disrupts familiar chains of cause and effect, the question is no longer, is causality broken, but rather perhaps causality is more complex than we once imagined. David Hume, writing in the 18th century, doubted the existence of any necessary connection between cause and effect. In an inquiry concerning human understanding, he suggested that we grow accustomed to repetition, but never truly see causality itself. A new force, if it exists, may simply confirm this intuition that the world does not operate like a simple machine, but like a deep network where influence does not always travel in straight lines. And when causality is no longer absolute, the limits of human understanding become unavoidable. Are there layers of reality that the human mind evolved for survival, rather than for comprehending the universe we'll never reach? Or are all limits merely temporary, waiting for more refined tools and gentler languages? Immanuel Kant distinguished between phenomena and noumena, between what we can experience and what exists in itself. In Critique of Pure Reason, he argued that certain aspects of reality lie beyond direct human cognition. If a new force suggests that many layers of reality remain hidden, this does not render human knowledge meaningless. On the contrary, it places knowledge in its rightful position, a humble effort within a vast universe. But the philosophy of science does not end with knowledge. When a new force carries the potential to control energy matter or even life itself, ethical questions can no longer be postponed. What responsibility accompanies new power? Have we matured enough to use it without repeating old patterns of domination and exploitation? Hannah Arendt warned that knowledge does not automatically give rise to wisdom. In Between Past and Future, she wrote, "The problem of evil will be the fundamental question of post-war intellectual life. A new force is not merely a tool, it is a collective moral test. It forces humanity to ask, who do we wish to become when we are no longer constrained by our former limitations? And finally, perhaps the deepest question of this night concerns the meaning of the universe itself. If reality has many layers yet to be revealed, if invisible forces continue to quietly shape everything, then meaning no longer lies in understanding it all, but in how we live alongside what remains unknown. The universe ceases to be a puzzle demanding a final solution and becomes instead a space that invites contemplation." Albert Camus wrote in The Myth of Sisyphus, "The struggle itself toward the heights is enough to fill a man's heart. Perhaps in science, as in life, meaning is not found at the summit, but in the journey of questioning a journey without haste, without coercion. Seen as a whole, the flow between the sections has never been broken. From new forces, we move to scientific truth. From truth, we touched causality. From causality, we encountered the limits of knowledge. From limits, we faced ethics. And from ethics, we returned to the oldest question of all. What kind of universe are we living in?" In the lullaby-like voice of the night, these questions do not require definitive answers. They only need a space safe enough to exist. When the mind no longer has to seal every uncertainty, it begins to loosen. And within that loosening, a deeper intelligence can quietly form. If you are listening and feel a gentle stillness opening within, that is not emptiness. It is the space of possibility where science and philosophy meet not to argue but to whisper together. Scientific truth may not be absolute. Causality may be more intricate than we once believed. Human understanding may have limits. Yet it is precisely these things that make the journey of discovery humane. And in this quiet night, perhaps the greatest comfort is knowing this: you do not need to understand the entire universe in order to be allowed to rest within it. Let these questions remain very light, very deep, and allow sleep to arrive not as an escape from knowledge, but as a gentle merging with the tender mystery of existence. When the night's current has carried us through questions of knowledge, ethics, and meaning, the gaze naturally widens very far toward the scale of the entire universe. There we are no longer dealing with individual particles or delicate experiments, but with vast structures, galaxies spiraling into one another. Filaments stretching across hundreds of millions of light years, clusters of galaxies gathering like islands suspended in a dark ocean. And within this quiet panorama, a question gently arises: if a new force exists, might it be silently shaping this entire architecture? Current models suggest that the universe resembles a network, a cosmic web where matter is not distributed at random but concentrated along invisible strands. Gravity plays the central role, drawing matter together over billions of years. Yet there are small details in this picture that do not entirely fit. The rate of galaxy formation in certain regions, the thickness of the filaments, the way galaxy clusters move as if guided by an additional unseen hand. If a new force exists, perhaps it does not need to be strong. It only needs to be persistent, like an undercurrent that creates no waves on the surface, yet is powerful enough to shape the entire riverbed. Such a force could subtly alter how matter gathers, allowing some regions of the universe to become rich with stars, while others sink into deeper shadow. There is something deeply familiar in this image. In inner life, great transformations rarely come from sudden shocks. They emerge from small tendencies repeated over time, thoughts, habits, quiet emotions, until one day the entire internal structure has changed. Perhaps the universe too matures in this way. Then there is the rate of expansion. Observations show that the universe is not merely expanding, but expanding faster over time. Dark energy is often named to account for this phenomenon, yet its nature remains obscure. If a new force operates on the largest scales, it may not be energy in the usual sense, but a wholly different mode of interaction between space-time and matter. Not pulling inward, but gently pushing outward enough to steadily increase the distance between galaxy clusters. Here, the idea of force no longer resembles a mechanical push or pull. It grows closer to philosophy, a foundational principle that does not intervene directly yet guides all motion. Spinoza wrote in Ethics, "Everything which exists in God, and without God nothing can exist or be conceived." If we replace the word God with the foundational structure of the universe, we can sense the same spirit. The deepest forces do not operate through command, but through presence. One of the most delicate places to sense the influence of a new force is gravitational lensing, the bending of light as it passes through regions of great mass. This is one of the rare ways to see what does not emit light. And here at times, light curves in ways that cause existing models to hesitate, as if an additional, very subtle factor were participating in the bending of space-time. Such deviations, if they exist, are not errors. They are whispers suggesting that the cosmic picture may contain a deeper layer where forces do not merely add together but interweave. Like music, not only notes, but harmony relationships that cannot be separated into isolated parts. Edmund Husserl suggested that meaning always arises in relation, never in isolation. Seen from afar, the universe too appears as an existential phenomenon. Large-scale structures do not exist alone, but are born from interactions extended across immense depths of time. The flow between sections remains seamless here. From the philosophy of science, we have opened into a philosophy of scale. The question is no longer what is correct, but what is quietly holding everything together. A new force, if it exists, may not disrupt the structure of the universe, but make it more coherent in a way we have not yet learned to name. And in the night's slow narration, the immensity of the universe does not overwhelm. Instead, it brings a gentle reassurance. Even the largest structures are formed from small interactions, repeated, patient, unhurried. There are no abrupt leaps. Only time. Marcus Aurelius wrote in Meditations, "Look deep into nature, and then you will understand everything better." To look deeply into the universe is not only to learn about galaxies and filaments, but about rhythm, about slow formation, about order arising without a conductor. If you are listening and feel small before such scale, let that feeling pass lightly. Small does not mean meaningless. In a universe woven by invisible forces, every point, no matter how small, is part of the whole. And in the same way, each gentle thought moving through your mind right now is shaping an inner space. Galaxies continue to turn. Filaments continue to stretch, light continues to bend, and if a new force is quietly present, it does not need to be found tonight. It only needs to be allowed to exist in imagination as an open possibility. Let that thought remain very distant, very calm. Let the universe continue weaving itself in the dark, and let you in this moment drift with the same rhythm of expansion, slow, deep, and safe enough to fall asleep. When the gaze has grown accustomed to the universe's vast structures, galaxies, filaments, silent clusters of stars, the night's current naturally drifts even farther toward the evolution of the whole. Not only how the universe is, but what it may become. And if a new force truly exists, it may not merely adjust small details, but gently reset the universe's long breath expansion or contraction, fading or renewal. In familiar models, the fate of the universe is often told through grand scenarios: the big freeze, the big crunch, the big rip, names that sound like endings. Yet if a new force exists, especially when operating on cosmic scales, these scenarios may no longer be inevitable straight lines. They become possibilities. And possibility, when heard in the night's slow voice, is no longer threatening. It opens space for contemplation. A new force could change how the universe expands, not simply faster or slower, but according to a different rhythm. Expansion might oscillate. It might pause, it might undergo transitions of phase, like a heartbeat not perfectly regular yet alive. If so, time would no longer be only an arrow rushing forward, but a flow with echoes. The idea of cosmic rebirth cycles of expansion and contraction would no longer be merely metaphor, but a physical possibility. Friedrich Nietzsche wrote in Thus Spoke Zarathustra, "All things are eternally returning and ourselves with them." Though spoken in philosophical language, the line resonates closely with cyclical models of cosmology. If a new force allows the universe to avoid a final eternal freezing, then existence may be a long composition rather than an abrupt final note. The evolution of the universe is not only written in space-time, but in the lifespans of stars. Even a very weak new force could influence how stars are born, burn, and fade. Stellar lifetimes might stretch longer, giving planets more time to stabilize. Or they might shorten, making the universe more dynamic, more intense. Such changes need not be large to become decisive, only persistent, only long-lasting. Here we touch a deeply human question. How much time is enough for life to arise? Enough for consciousness to form? Enough for questions to be asked? In this way, the universe is not merely the backdrop of life, but the condition of possibility itself. A new force could fine-tune those conditions, much as a deep breath can soften the entire body. Then there is matter density, the delicate balance that determines whether the universe will continue opening or begin to turn back upon itself. If a new force interacts with matter in ways not yet known, it could subtly shift that balance. Not by reversing it at once, but by tilting it ever so slightly. Over billions of years, the outcome would be entirely different. Here, time becomes the ally of subtlety. Henri Bergson wrote in Creative Evolution that time is not a series of discrete moments, but a lived duration, a continuity in which change accumulates into new quality. The universe evolves in this way, and a new force, if it exists, may be working within that duration, unhurried, unobtrusive. The flow between sections remains seamless. From large-scale structure, we move to long-term evolution. From evolution, we touch destiny. Yet destiny in this lullaby-like narration is not rigid fate. It is openness. A universe may age in many ways, just as a human life may. There is a quiet comfort in imagining that the universe's fate is not locked in place. If a new force exists, the universe need not end in coldness or tearing apart. It may find other paths, softer endings, slower conclusions, or even new beginnings. Not because the universe wants anything, but because its structure allows more than one story. Albert Einstein wrote in The World as I See It, "The most beautiful thing we can experience is the evolution of the universe widened by the possibility of a new force becomes beautiful in this sense, not because it offers certainty, but because it preserves mystery. If you are listening and feel your thoughts drifting very far away, allow it. There is no need to pull them back. In a universe that may expand, contract, or be reborn, letting the mind drift is not a loss of control, but a form of attunement, like a leaf resting on a river without needing to know where the water ends in order to be at peace. And then, as we return closer, we notice that questions about the universe's destiny mirror very personal ones. How will this life open or close? Will we age into rigidity or into flexibility? Will we freeze or will we transform? A new force, if it exists, does not only rewrite the universe's script. It reminds us that there is no single ending for all existence. There are side paths, slower rhythms, returning cycles. In this quiet night, you do not need to choose a scenario for the universe. Let it continue evolving in its own way, very long, very deep. And allow yourself to do the same, to evolve not through effort, but through permission. Permission for time to do its work. Permission for unknown forces to remain as possibility. Permission for sleep to arrive like a gentle expansion where every question settles for now and existence simply being becomes enough. When the night's journey has carried us through the largest questions of the universe's structure and fate, the current of thought naturally turns closer, not to narrow its scope, but to touch the ground. For any new force, however deeply hidden within space-time, will ultimately leave traces in human life. Not loudly or all at once, but gradually seeping into how we learn, collaborate, tell stories, and look at one another in a world increasingly bound together by knowledge. If a new force were discovered, the first technologies to feel its influence might seem familiar. Earth observing satellites with greater precision, AI capable of subtler data analysis, robotics operating in environments once thought impossible, and new materials that allow humanity to build lighter, stronger, and with less harm. Yet, in the night's slow voice, what matters is not the list of technologies, but the shift in spirit behind them. Technology would no longer be merely a tool for control, but increasingly a means of listening to the earth, listening to the universe, and ultimately listening to ourselves. There is something deeply gentle in realizing that the most profound discoveries in physics often lead to applications that demand delicacy rather than brute force. Satellite technology does not only let us see farther, it allows us to see more clearly what is fragile climate oceans, life. AI does not merely accelerate processes. It asks us to rethink intelligence itself not as a privilege, but as a broad spectrum of cognitive capacities. Alan Turing once wrote, "We can only see a short distance ahead, but we can see plenty there that needs to be done." A new force, if it appears, does not instantly open a distant future. It clarifies what needs to be done now with greater care and deeper responsibility. From technology, this current spreads into international cooperation. The universe belongs to no single nation. The forces of nature carry no passports. To search for them requires collaboration beyond borders, ideologies, and competition. In this quiet space, science becomes one of the few domains where humanity must learn to trust sharing data, sharing doubt, and even sharing mistakes. Hannah Arendt suggested that a common world exists only when people are willing to care for it together. Research into the universe at its deepest level is such an act of care, preserving the possibility of dialogue in an age prone to fragmentation. When scientists from many cultures examine a faint signal from distant space, they share not only data, but humility before what remains unknown. And perhaps the most enduring influence of a new force would appear in education and communication. When physics is no longer confined to dry equations but told as a deeply human journey of discovery, it becomes a source of inspiration. Children do not only learn about gravity or quantum mechanics, they learn that the world still holds open questions and that asking questions is itself something to be valued. Carl Sagan once wrote, "Somewhere something incredible is waiting to be known." Those words are not meant only for scientists. They belong to anyone who has looked up at the sky and felt a quiet curiosity. Science communication, when spoken slowly and honestly, can nurture that feeling not through spectacle but through trust in the listener's intelligence. The flow between sections remains unbroken. From the evolution of the universe, we move to the evolution of society. From invisible forces, we touched very tangible human connections. A new force, if it appears, would not only alter physical models, it could change how humanity understands its role within a larger picture. Here, the idea of global responsibility becomes clearer. When we see the universe as woven from subtle interactions, we begin to see society in the same way. Every small action in education, in media, in policy can travel farther than we imagine. A new force in nature reminds us that the world does not operate through isolated collisions, but through influences that unfold over time. Edgar Morin suggested that complex thinking is essential for facing this century. As cosmology deepens, society too is invited into greater complexity. Not separating technology from ethics, knowledge from responsibility, progress from care. In the night's lullaby-like voice, none of this demands urgency. It does not ask you to act immediately, to understand everything at once, or to change right now. It simply whispers this: you are living in a time when caring about the universe is also a way of caring about one another. When science is no longer the story of a small group, but a shared language for imagining a common future. If you are listening and feel a gentle softening within, that is not an escape from reality. It is a sign of connection between knowledge and feeling, between sky and ground, between unknown forces and familiar life. A new force, if discovered, may transform technology, education, and communication. Yet perhaps its deepest impact would be this, reminding us that we are living together in an unfinished universe, and that for this very reason, each generation has the chance to add one very light stroke. In this quiet night, you do not need to carry the responsibility of all humanity. It is enough to hold on to a small feeling that caring about science, about the universe, about our shared future can begin very simply with listening. Let these stories drift slowly. Let technology, knowledge, and hope settle into a warm ground. And let you, in this moment, rest not apart from the world, but gently holding it within a peaceful sleep. English translation, closing passage. Philosophical, slow and soothing conclusion. And now, as this journey slowly draws to a close, not with a definitive conclusion, but with a silence deep enough to rest within, perhaps what matters most is not what you have just heard, but what you no longer need to hold on to. We have traveled a long way together, through familiar forces and unnamed ones, through the structures of particles of stars of a vast universe, through questions of knowledge, ethics, and humanity's responsibility in a world that is still unfolding. But if everything were to be gathered into one simple thought, it might be this: the universe does not require us to understand all of it in order to exist within it. Perhaps beyond the four familiar forces, there are still others quietly at work. Perhaps reality is deeper than we once imagined. But perhaps, and this is important, we do not need to know everything right now. Like the night sky, you do not need to count every star to feel its calm. At this point in the night, allow your mind to soften very gently. No more analysis, no more remembering, no more searching for a final answer. Carry only a vague but steady feeling that this world is wider than your worries, deeper than the thoughts repeating themselves, and more patient than any pressure you are carrying. Invisible forces continue to weave the universe. The rhythm of expansion goes on slow even. And in this moment, you do not need to do anything at all, except rest. Leave the questions behind like stars fading as your eyes close. Let sleep arrive not as an escape, but as a return to the natural rhythm of breath, to the original stillness the universe held long before names, long before forces, long before questions. May your sleep be deep, and when you awaken, the universe will still be there, quiet, vast, and full of things that do not yet need to be understood.